In this presentation, we are going to look at the Poisson approximation, the Poisson distribution and the normal approximation of the Poisson distribution. The number of claims arising in a period of 1 month from a group of policies can be modeled as a Poisson distribution with a mean of 24. Determine the probability that fewer than 20 claims arise, that's important there, in a particular month. Now, if we were to do that from first principles, now we could use a table if we had a table, statistical tables that allowed us to check the mean of Poisson mean of 24. If that sort of is accounted for in the tables, it may be, may not be. We could do it out from first principles, which means calculating the probability of x equal to 0 plus the probability of x equal to 1, all the way where x is the number of claims, all the way up to the probability of x equal to 19. That's not what we want to do. So that's why we use a normal approximation. Okay. Now, before I get into the normal approximation, just remark that it's important to know these correction factors and how they're used in each instance. Okay. Now, we could go fewer than 20 means less than 20, or less than or equal to 19. Okay. So, and also, so less than or equal to, what are we going to use here? Less than or equal to 20. We're going to use this one in this instance. Okay. It depends on how you interpret the question, but just as long as you're consistent with how you do it, with regard to your correction factors and how you decide to phrase the question. Okay. So, actually, they work out both the same in this instance anyway, the one and the one above it. But essentially, this is the one we're going to use here. Okay. So, the probability of... first off, we're going to use a normal approximation with a continuity correction. And what we're going to state here is that the mean is 24 and that the variance is 24. And we're going to use that in our... So we're going to use the Poisson mean and the Poisson variance as our estimates for the normal mean and the normal variance. Okay, and I have it written there as the square root of 24 squared just to emphasize the standard deviation. Okay, so using our correction factor, we're going to restate the problem as x less than or equal to, less than 19.5. So this is the Poisson. And this is the normal approximation of that using a correction factor. Okay, so we're pretty much set up. The mean is 24. The standard deviation is the square root of 24. The value that we're interested in is 19.5. Okay, so essentially what we're doing here is calculating a z-score. And really, probably should be a bit of calculator work now. It should be straightforward enough. Probability of actually should be just less than there. Not that it matters with when you could use a continuous distribution, but it might as well be consistent. What is the probability of z less than minus 0.92? Little typo there. It is 1 minus 0.82, and that should work out to be 0.18. Okay, so that's it there.